Hello there, and welcome to our new video on implicit differentiation. You can see our objective right there, that students are going to use implicit differentiation in order to find derivatives of implicit relations. If you notice it says relations and not functions, we'll talk a little bit more about that later. We have thus far developed basic techniques for calculating the derivative dy dx when y is given in terms of x by a formula, such as something like y equals x cubed plus 1. We've been able to easily find that derivative. But suppose y is determined instead by an equation such as x to the fourth, or y to the fourth, plus x times y equals x cubed minus x plus 2. In this case, we have to say that y is defined implicitly. How can we find the slope of a tangent line at a point on a curve such as this? Well, we have to do it the exact same way we've had to do it in the past by finding the derivative dy dx. So, although it may be difficult and even impossible to solve for y explicitly as a function of x, we can still find dy dx using a method known as implicit differentiation. So take a moment, you might need to pause the video so you can think about this. What does it mean to be implicit? And what does it mean to be explicit? So think about what you've learned in English classes or throughout the years of what it means to be implicit or explicit. We're going to move on, and again, you can pause the video so you can think about that. Here are some definitions that I found. Implicit, implied rather than expressly stated. Implicit agreement. Well, we're really concerned with this one, number 4, mathematics. Having the dependent variable, not explicitly expressed in terms of the independent variable. So your dependent is y and your independent is x. So that's something new for you. Explicit, if we look down, fully and clearly expressed or demonstrated, leaving nothing merely implied. Unequivocal. Explicit instructions, an explicit act of violence, explicit language. We're concerned with down here number 6. Having the dependent variable, that's y, expressed directly in terms of the independent variables. That's what you're used to seeing, explicitly defined functions. So now we are going to do a little, show you the difference between finding things, the derivatives, dy dx, implicitly versus explicitly. Here is the curve, and you can see why it's called a relation and not a function. Y to the fourth plus xy equals x cubed minus x plus 2. We'll come back in a little bit and find that derivative, dy dx, implicitly. Let's first look at this. Find dy dx. Well, if you look at this, it's written a little different. We usually write things as a function notation, but f of x equals, but we can still take the derivative of this. We're going to take dy dx. We're finding the derivative of both sides. I'll do the easy part for you. I'm just kidding. We'll do it all together. We're going to use two rules. Excuse the bell. The product rule, I hope you see, and the chain rule. So u times the derivative of the outside using the chain rule, evaluate the inside, times the derivative of the inside plus v u prime times 3x squared. I know it's a little small there. So now what we're going to do is we are going to do just some simplifying. So you see here 2 times 4 is 8, 8x cubed times this quantity 2x plus 1 cubed, and then plus 3x squared times 2x plus 1, the quantity to the fourth, equals 0. Alright, so there's the derivative. Us using the derivative rules that we do that. We can do something very similar to that with an implied, when it's implied. So if you look again, there's a product here, and I'm going to show you how to do implicit differentiation. On the next slide, you'll see some guidelines for that. So we're going to use the product rule again, uv, so we'll do u v prime. Now since this is implicit, we're going to treat this like the chain rule. So we're going to take the derivative of the outside, evaluate it at the inside, times the derivative of the inside. So the derivative of y is dy dx plus y to the fourth times 3x squared, and again on the other side is 0. So this we use the same way we did this over here. The difference is our derivative inside, since this is an implicit relation, the derivative is dy dx. So now let's solve for dy dx. Well, we can do that. We can subtract this from both sides. So we get x cubed 4y cubed times dy dx equal to negative 3x squared y to the fourth. And that is just me subtracting that using some algebra. Now I'm going to get dy dx by itself by dividing both sides by this quantity. So dy dx equals negative 3x squared times y to the fourth all over 4x cubed y cubed. This is the derivative, dy dx, of this implicit relation. This still means the exact same thing as it meant when we were finding derivatives before, and we can do all the things we did with derivatives with this. So let's look at the guidelines. Here are the guidelines for finding implicit differentiation. Again, you may want to pause and copy these down. I'm just going to highlight some of the things with this. We're going to differentiate both sides. We're going to take the derivative with respect to x. Okay, first thing we're going to do. Then we're going to collect all the terms. Now in that last example we only had one term, but sometimes we'll have multiple terms involving dy dx on the left side of the equation and move all other things to the right. We're going to factor out the dy dx out of the left side of the equation. Then we're going to solve for dy dx by dividing both sides of the equation by the left-hand factor that does not contain dy dx. Interesting. So now what we're going to do is we're going to go back to that one relation that we saw that we kind of started with, and we're going to take the derivative of that using these guidelines. Oop. There it is. Alright, so you see what the curve looks like. Now we're going to take the derivative, find dy dx. So again, both sides. So this is a y, so we're going to do 4y cubed, derivative of the outside, evaluate the inside times the derivative of the inside, which is going to be dy dx. Plus, here's a product, so we're going to use the product rule. Students tend to forget that when they see this. So the derivative of y is 1 times dy dx plus y times the derivative of x is 1. Now the other side, pretty easy since there are just x's there. So now we're going to collect everything with dy dx on the left side. Well, that's good, they're already there. Move everything else to the right. So is there anything, look, this guy needs to be moved over. So we get 4y cubed dy dx.
Do you know when the drill is?
Plus x dy dx equals, now we're going to move this to the other side, 3x squared minus 1 minus y. Now that the dy dx's are over here, we are going to now factor out dy dx. We get 4y cubed plus x equals 3x squared minus 1 minus y. Now we're going to divide both sides by that to get dy dx all by itself. And there is our derivative, our dy dx implicitly. Sorry about the bell. All right. Here's another example that we have, and now to show you with the dy dx, we can do everything, slopes of tangent lines, finding slopes of tangent lines, equations of tangent lines, anything and everything that we did with derivatives before we can still do. So why don't you take a moment and see if you can't do this on your own. So pause the video, see if you can't use those guidelines and find that. Hopefully you had an opportunity to do that, you paused it, but here it is. The derivative of that, and then now it's 2y times dy dx because of that y. We got to remember there's some function of x in there. 0. Things that do not have dy dx on to the left side. So dy dx, I'm sorry, 2y times dy dx equals negative 2x. Divide both sides. And we are left with, my little arrow, dy dx equals negative x over y. Slope of all the tangent lines on that circle. Now what could be hiding behind here? Oh, find the slope of the tangent line at that point. Well, how would we do that? Well, we have the slope of the tangent line right there. So now let's just plug in. 3/5 is the x. So we have negative 3/5. And here is the y, which is 4/5. And then when we solve that, you'll see they become reciprocals. We get negative 3/4. So that is the slope of the tangent line at that point, 3/5, 4/5. All right, so I hope you enjoyed this video on implicit differentiation. Again, come prepared in class with questions, and we're going to be doing some problem solving in there. So play it as many times as you want, and enjoy.